I would like to go through one problem from your textbook. Problem I am interested in is on page 692 of your textbook. Its problem number is 16.30. When you read that problem, you find out that it's related to average baseball salary from 2000 to 2010, and you have been asked to fit a third order autoregressive model to average baseball salary and test for the significance of the third autoregressive model. Basically, you have been asked to determine if the third order autoregressive model is appropriate. And then in part B, it says it's possible that may not be the case, and you might have to go and run a second order autoregressive model. And again, you need to determine if it's appropriate or no. And also, it's possible that may not be appropriate, so you might have to go to the first order autoregressive model in part C and test that at alpha equal to 0.05. And lastly, you have been asked to choose the best model and forecast the average baseball salary for 2011. So let me go to Excel. I have already data stored in Excel. So let me generate data for third order autoregressive. So I'm going to go and copy this column and bring it down one. So it would be lag one. Another time I'll do it one more time. This would be lag two, and this would be lag three. And now, if I need to run a third order autoregressive, I'm going to just pick this much data and save it somewhere here. So now, obviously, this is the year column. This would be my YT column, and this would be YT minus 1, YT minus 2, YT minus 3, the third order. If I use a regression terminology, this would be Y column. This would be like X1 column. This would be like X2 column. This would be like X3 column. So I need to go to data tab and try to find out uh, appropriate statistical method, which is regression analysis in this case. I go and come up with that. Now, first thing I want to identify Y, which would be here in each column. Then my X1 to X3 would be rear. So I'm basically using regression. There is no label here. So I'm going to just go and put the output somewhere adjacent. Let me put it in M1 cell. Now, if I go through this, let me try to enlarge it a little bit so we can see it better. And now what I need to do here, actually just concentrate on this row. Let me highlight that and let me make it. Now, my p-value for the third order autoregressive is 0.821. And now, under HO, I would say that the um, slope for the third order autoregressive is 0. Under alternative, I say it's different from 0. So if I look at the p-value and compare it with alpha, which is 0.05, obviously I am not going to reject HO, so I am saying that the slope for the third order, statistically speaking, is 0. Therefore, I could conclude that the third order autoregressive is not appropriate. So now I'm going to go to part B, and I try to basically run the second order autoregressive. So let me first use my data, and for the second order autoregressive, I'm going to start from 2002 data, and I'm going to pick up this much information. Now, I'm going to copy this and put it right here. So now, obviously, this is year again, and now this would be in autoregressive terminology, it would be YT. This would be first autoregressive, YT minus 1. This would be second, YT minus 2. And now I need to run a regression again. So let me go to data analysis, and let me um, try to run the regression or autoregression. Now, uh, first, my YT, it's going to be the same as B column. Now, my YT minus 1, YT minus 2 are stored here. So I'm putting them from C1 to D9. And then let me put the output also right away here in G1 cell. Now I'm going to go through these. Again, let me enlarge it a little bit. Now this time I'm looking at the problem part B. I'm trying to see if the second order autoregressive is appropriate. Now looking at the information here, I know the p-value is 0.397 and my alpha is 0.05. So under HO, I have the second order autoregressive slope is equal to 0. Under alternative, I have the second order autoregressive slope is different than 0. Now, my alpha is 0.005 and my p-value is right here. It is 0.397. So obviously my p-value is more than alpha. Again, I'm gonna make a decision, and I would say since p-value is more than alpha, I do not reject HO. So I can conclude that the slope for the second order autoregressive is 0. That implies that the second order autoregressive is not appropriate, and I need to go to part C. So let me go back to get the data for it. So when I go to do part C, which is a run of first order autoregressive, I'm going to start from 2001 and I'm going to highlight this much and copy it. So I'm going to go and copy it here. Okay, I already have that. Now I'm going to again go to the data tab. I'm going to go to regression one. And first, let me clean up what I have from the previous part. Now, my YT is right here. That's the same as Y in regression analysis. And my YT minus 1 is the first order autoregressive data is here. It's the same as X in regression analysis. And my output, let me put it in F1. And I'm going to go through this. Again, let me enlarge it. And again, I'm going to go to right away to the result I have. This is what I have. And now my p-value is, you got to be careful here because the p-value is given in scientific notation. It's a very, very small. I can see it on the top over there. It is basically I have 40 for the small point. We put it here, 0.00001. It's almost zero, to be honest with you. And then my p alpha is 0.05. So now I'm looking at the part C of the problem. The problem wants me to determine if the first order autoregressive is appropriate. So I have under HO the slope for the first order autoregressive equal to 0. Under alternative, I have the slope for the first order autoregressive is not equal to 0. I'm comparing p-value with alpha. Obviously, p-value is smaller than alpha in this case. P-value is almost 0. Alpha is 0.05, so I can conclude I have to reject HO. By rejecting HO, I am saying that the slope for the first order autoregressive is statistically different from 0. It means that this model is a good model. It means statistically it's significant. And therefore, if I need to predict something for 2011, obviously I could go and do that. So I'm going to use the previous year information because my model is this, YT equal to uh, YT is Y, let's say Y 2011 is equal to, I'm predicting that. My intercept is here in F, I'm sorry, G17 plus my slope is in G18, and then I multiply that by uh, previous year's actual sale, which is 3.27, which is, I'm going to write it down here. If I do that, predicted value, oh, I'm sorry, I have to. The predicted value for 2011 would be this much. Predicted salary for 2011. It's going to be 3.32. 3 million, 3.32. That's what I have. That's the salary for 2000, average salary for 2011.